our lesson about logic. We have logic. Logic is the science of correct reasoning. And the one who is famous in this subject or in this matter is Aristotle. So in logic, we have so-called proposition. This proposition can be true or false. But remember, one of the characteristic, but not both. It can be true, but not, it can be false, but not both true and false. That is the proposition. So, this proposition can be true or false. And these true or false are the variables for logic. So, if in algebra, we use variable to represent numbers, in logic, we use variables to represent proposition. And these variables are the representation of the proposition. Actually, true or false is same term for numerical constant. Therefore, we can say that true or false is also a numerical constant. Even though this is not number, but definitely it represents something. It represents numbers. It represents proposition. It represents premises. Okay? Now, let us have the idea of the different connectives, the symbols, and the type of statements that are commonly used for logic. So we have here connectives, symbols, and the type of statement. I know that you are very much familiar in English. In English, there are declarative sentence, imperative sentence, interrogative sentence. In logic, there are also sentences. And that will fall under the types of statement. Let us start with the first connective. The first connective will be AND with the symbol hat. And the type of statement is what we call conjunction. So there are two propositions combined by the connective AND. And that is what we call conjunction, having this kind of symbol. The next one is OR. Kabaliktarin nito, we have like V, and that will be this junction. So, there are two propositions connected by OR. And the next one is what we call NOT. And the symbol for NOT, there are two symbols commonly used nowadays. We have this one or this one. If you will encounter these both symbols, these symbols represent not, okay? And not is for negation. When we say negation, it contradicts the statement. Next, we have if, then, having the symbol arrow, with one arrowhead, and this is what you call conditional statement. If you will study, then you will pass. Then we also have if and only if. If and only if, or commonly having a abbreviation of IFF. It means we have this kind of symbol, and that is biconditional. Meaning to say, it is the combination of two if-thens, or two conditional statements. So, our truth table, or the analysis for logic, will play, or will go with these connectives, with these symbols, and with this type of statement. So, allow me to discuss to you the different formula or the different answer or conclusion applying these connectives. Okay? So, let us have these clues. Now, allow me to write the clues here. Okay. So, if you will encounter AND, take for example, you have AND here, use here. For and, if the first statement is true and the second statement is true, therefore the answer will always be true. Therefore, the rest will be false. T and T is always true. True and false is false. False and true is false. And false is false. So it will only be true if both statements are true. Then the rest will be false. That will be for conjunction. And for disjunction, we have here at least one true that will be equal to true. If we have true or false, that will be equal to true. False or true, that will be equal to true. True or true, equal to true. And false or false, that will be equal to false. Why? Because false or false, it has no true statement. Now, let us have for if not true, therefore false. Otherwise, if not false, therefore true. And for our if then statement, we have here true, if true, if true then false, that will always be false. True, if true then false, that will always be false. Then the rest will be true. True, if true then true, true. If false then true, true. If false then false, true. It will only be false if we have true then false equals false. Next, if and only if. If both are true, that will be true. If both are false, that will be true. Therefore, true, if and only if true, that will be true. And false, if and only if false, that will be true. So these are the ideas that you need to memorize or you need to understand in order for you to complete the truth table and in order for you to have your tautology, fallacy, and contradiction. So we have for and or conjunction, true and true will always be true, then the rest will be false. At least one true, that will always be true for or. And if not true, therefore false, and if not false, therefore true. And for if then, if true, then false, the result will be false, then the rest will be true. And if both true and both false, then we have always true. That will be for if and only if. So, we will be using this idea to prove if the given propositions are true or tautology, or valid or invalid. So with our next video, I'll be discussing or we'll be applying the idea of truth table. Stay tuned for the part 2 for truth table, applying this concept and idea.